Thank you, Mr. Chairman. And good morning, everybody, and thank you for attending. Okay, so the Pavitra Ganga project is a project financed by Europe and the government of India. It tackles two specific areas, Delhi and Uttar Pradesh, Kanpur Nagar region. The purpose of the project is to provide solutions for water reuse and wastewater treatment. But in a circular economy, water reuse and wastewater treatment is actually only the beginning of the journey. The remaining part that is left is how to solve all the problem of the waste that is generated by it. Yeah? So in a circular economical approach, you need to define a methodology that would allow you to unlock all the resources that would be bound to the water cycle, and even more than that. So this is what this presentation is about. At the right side, so I'm gonna just mention initially the methodology. So at the right side, we look at the asset analysis. So we go to the area, we see the asset that is present, we try to map it and to determine the remaining value of the asset to have an idea of what we would want to rehabilitate. At the left side, you see a social environmental screening. This was conducted within a lot of work packages of the group. Some of this work have been actually already presented in this conference. We looked at the presence of stakeholders. Policies and regulation was presented yesterday by Gabriella. And the environmental criticities, and this is what I will start with. Then what we did, it was to try to make a decision-making framework for circular solution selection. And the idea is that what we do is that we select ideas that are present in literature, we make out of them standalone scenarios, and we try to rate them. And what do? Actually, we look at the relation that these standalone scenarios have to the system according to specific aspect of circular economy. We try to see if there is a possibility to unlock this circular pathway when they are blocked, and when we try to rate them. So this is actually a semi-quantitative assessment of possible circular standalone scenarios. The area where we go is actually Kanpur. And if you see, like at the right side, there are some red spots. So in this area, we have wastewater treatment plants, we have tanneries, and we have farmers. And this is a very interesting composite economy. There is present infrastructure, there is chance of financing, and that's why the Pavitra Ganga is there. If we talk about water quality, it is bad. But it's not the point that there is no water, there is water, but the extraction of the assessed groundwater bodies is pretty high, and that brings it to the fact that 56% of the groundwater bodies is in a semi-critical state. Well, what do they use water for? Farming. If you look at surface water, it has been already highly reported in literature, the condition of the surface of the water there, and it is pretty bad. For surface water, we have problem with pesticides and heavy metals, in that specific area, chromium, due to the tanneries. If you look at the effluent is not really suitable for irrigation, definitely because of sulfur and sulfide, but of course also because of chromium. Groundwater is also polluted with a high level of arsenicum and lead. So the situation where we are, I schematized it here. So we have tanneries, they discharge in their own treatment plant, which is overloaded, but they also illegally discharge in the city, so through the sewer trunks. The water of the city, the one that is actually collected, go into the Jajmau STP, 130 mld. The sludge goes into a digester is not working, so it goes straight to a sludge drying bed, it's dried, and then farmers take it. The water goes into the canal, and then the farmers use it. So you can see that there are some circular pathways already activated, because farmer tanneries, they need to find a solution for their issues, but they are not properly activated. The second important issue is that there is actually almost unlimited resource of organic stream. Crop residue, 60 million tons per year. Food waste, 12 million tons per year in the area of Uttar Pradesh. So what we did, we went into literature, was quite some reading, and we tried to find out some ideas that could actually be suitable for the areas. And I consider them according to the utility framework of the IWA association, so divided them by water, material, and energy pathway. Then it comes to the point to look at them, so to look at them in relation to the system. So the goal of the Pavitra Ganga here is to try to find the right way to look at the wastewater treatment plant, which is in fact the focal point where all the resources are coming. And that's the focal point where actually the ideas could come out and the circular economy could be deployed. That's how we see it. I'm proud to say that within the Pavitra Ganga, really in the spirit of the circular philosophy, we tried a participatory approach. We had sitting together. This was conducted by people of TU Delft. We had farmer association, tannery association, and water utilities sitting on the table, try to find solutions and try to see what was the common awareness of the problem. And what was it? If I have to very briefly summarize it, I would say that everybody knows that those wastewater treatment plants do not work properly, but the utilities, they ask a participation in cost. Yeah? And the farmers and the tanneries do not want to pay. They do not have that much money, because they say the water is not good enough, but also because their business activities, they are very limited in profitability. So a solution would be to have green technology adoption in their activities so that they could actually pay a bit more. On the other side, what was very clear, it was that there should be more awareness in the health risk of the common practice that are used now. Another very important aspect of circular economy is to design out the pollution. What do we want to attain? We want to attain energy, water, compost, and phosphorus. So water is only the beginning of the journey, and we have a lot of materials that are available, and this is actually where the challenge is. We have primary sludge, food waste, water, crop residues, septic material. We have a lot of stuff, but it's not activated. And two main points in this principle that we considered was decarbonize and separate food and feces streams, because this was really asked by the community. Yeah? Now, if you look at the decarbonization, there could be a lot of opportunities in there. Yeah? So possibility of co-digestion, and that's what we're testing in the Pavitra Ganga with the Andikos project. Then the other possibility could be actually to use the crop residues. 6% of total electricity of India could be actually produced by crop residues that are there. And if you would combust them with coal, you could actually substitute 25% of the current coal consumption with subsequent substitution of fossil fuel. So it's an impressive opportunity. If you look at fertilizer, something that would really be used on site, Aquafin has a lot of experience. And we have been operating already since 2010, large-scale struvite reactors, both from digestate and centrate. And what we have learned, what we know, is definitely one important aspect. The recovery of phosphorus is pretty low. It's only 15% that you may recover, whereas if you would do it from the ashes, it's 85%. But there are some other important aspects of struvite recovery. The effective molar ratio of magnesium to phosphorus is 1.5. It's pretty high, and this contradicts the principle of circular economy. Yeah, you want to make phosphorus, but you're digging magnesium from the soil, and that's not good. Also, it would need a BioP activity that would be properly working, and who is going to assure us that there will be enough BioP activity in the wastewater treatment plant as such. Also, pure product purity. And the cost as well, it's pretty high compared to the possibility of having pure phosphorus, which could be sold from 2 to 5 euros. So before trying to rate the different standalone scenario, we went into the supply and demand analysis of all the pathways that were activated. So this is first to understand the inputs of the process, but also to understand if it is possible to activate circular pathway. Now, it is pretty long, so I just discussed the energy pathway because it's also simpler. And one possibility is co-digestion. So why digestion failed there? Why don't they digest? They don't digest because actually they were not properly selecting the organic streams. They put together secondary sludge, primary sludge, and it wasn't really working. And probably there is also some metal toxicity related to the digestion. But in fact, they have not used the proper organic streams that could allow to do a good co-digestion. So there is supply, the material is there, the facility is there, but at the moment there is no demand. And we are convinced that we can activate the circular pathway. The other possibility is co-pelletization of secondary sludge. Yeah? For this, there is a huge demand in India, but at the moment there is no supply in the area. And this is actually a very interesting option. So what I do to try to rate all of this, LCA would be better, but only in ideal condition. In reality, I do not have the data to go that far, and maybe we can discuss later. There are also quite some drawbacks of LCA approach. I try to rate all the different standalone scenarios in a 2D chart. Rolling economy, so which is like the economy that is generated by the activated standalone scenario in comparison with the local economy. And on the y-axis, a composite parameter, the circular potential. The circular potential is composed of 5 different steps. One of them is the rating the toxicity of the product that you deliver, how efficient is the process. For instance, true white would be very fuel efficient. The destination after use of the product, the utility during the use phase, that is to say the lifetime of the product that you produced and the lifetime of the process itself, and then the input in the production process, so the reliability of the supply chain, yeah? And also how much of the material that you input is actually recycled. When we put that all together, I come up with some figure that guides me into getting an idea of what could be best and what could not be used. And for the energy pathway, that was visible from the beginning, the sludge copalletization actually can activate a huge actually economy. And of course, at last, the co-digestion of secondary sludge. So at the end, we have been rating standalone scenario with this sort of semi-quantitative assessment, and then we do go for a cost-benefit analysis, and this will be done by my colleagues in the next deliverable of the project. What I'm going to present you is the decisions that have been taken based on this technology. Artificial recharge costs a lot of money, everybody knows this. Water for the industries is the best way to create value. The problem there is that the farmers take water either from groundwater, which is actually cheap, or actually for drinking water, and there should be actually a tariff factor playing. Water for farming is okay, but only at the moment that we reduce the toxicity of it. That's why the colleagues are testing a dynamic membrane system that could be actually applied to provide a protection from pathogens. If we go for compost production, several aspects, and especially toxicity, say do not use secondary sludge in there. Yeah, it's full of metals. Yeah, and this is what they were doing so fast. And we would do it through food waste. Phosphorus, I kind of described it already. Struvite formation for several aspects of the circular potential would be discarded, and we would instead go through copalletization, copellets with crop residues that, according to literature, already provide a sufficient caloric power, and incineration in the energy offsite system. That could be either a mono incineration, but the mono incineration would require a huge investment, or simply in the existing power plant. Then from the sludge ashes, you could try to do phosphorus. From a sludge mono incineration, it would work very well. From a power coal central, it's something to test. We would not do energy, we will not produce energy from food waste. It is something definitely possible. It's already tried. There are very successful projects in India, but it's a choice. And then the secondary sludge would not be used for energy on site. We would do it with primary sludge and enriching the primary sludge with food waste and septic material. So at the end, what we're proposing is the following. The tannery effluent, there shouldn't be any legal discharge, theoretically. The CETP will be equipped with chromium recovery. This is a fact. They're already working on it. It's actually under commissioning. The sewage plant would be treated, of course, in the Jajmau STP, and what matters in the matter of this presentation is to have primary sludge treated and enriched by food waste, and the secondary sludge would go to the sludge drain beds. Sludge drain beds, it's an important detail, they are very important to keep high the business value of the copalletization as such, because then it becomes only about pressing it. Yeah. Then the enriching with the crop residues, the copellets, and the copellets, they can activate two potential markets. One is the domestic market, and the second one is the possibility to use it in a power plant with substitution of fossil fuel, inert material, and phosphorus recycle. Conclusion. So we use the semi-quantitative method to guide us in screening circular solutions. In presence of a complete database, a CBA is set to confirm the goodness of the result. The Pavitra Ganga technologies are at the moment being tested to retrofit the Jajmau STP. Lab tests should actually be conducted to test the methane yields of the co-digested streams, but it's really about finding the optimum. There is no doubt that this is a good idea, and the phosphorus recovery of the selected ashes. I want to thank the project of Pavitra Ganga. We are visible in social media, and I want to acknowledge my partners. Thank you very much.
Thank you, Dr. Fenu. Thank you for also managing time well. I think we have time for one question. If anybody has a question, yes, in the back.
Hello. Yeah, thank you for the wonderful presentation. In the decision-making framework, like you have mentioned about the socio-economic screening. So what kind of parameters are you tracking in the social aspect, and how you are assessing them?
So there are like 3 phases. The first phase, let's put it like that. So I didn't have complete data. That's clear, because one possibility would have been to go to an LCA, but I didn't have enough data to do that. And there is also some drawbacks in the LCA in such a complex system. So I have like two stages. So the first stage is the relation to the system of the different selected technologies, of the different proposed technologies. And these steps, they help me, guiding me through, actually, in the circular potential definition. And the calculation as such, they are done in the circular potential, and they are like those 5 steps that I said. And it's actually based on toxicity. There is, it's actually based on the data that is available. But I'm only looking at them in relation with each other. I don't provide absolute values, because I'm not able to do that at the moment. In fact, what you do not want to find, there is not one right answer. There is not one right answer. There is, I think, a good knowledge of the situation and some ideas that could be more mature to be produced. When you look at, for instance, the demand and the supply, there you get an idea of what could be more properly activated than other pathways.
Okay. And with that, we'll move on. Thank you, Dr. Fenu.